sine. Another force is this one, plus 71.53 into 1. Now is there any other force? Because when I will take a moment at the D, 40 into 0, because I'm interested the value of bending moment at D. So 40 into 0, and this answer comes to be 52.33 plus sine. We achieve the answers is of 52.33. Right, let us write down 52.33. How to join these 2 points? Because this one A and D, there is not a single load. I have to join with the help of the straight line. Because there is no load between A and D, I have to join with the help of inclined straight line. Now let us take at E point, what will be the answer for us? Next, moment at E is equal to minus 10 into 1.2, that is the total load, multiply by perpendicular distance 1.2 by 2 plus 1 plus 1, because I am interested to find out the moment over here, and with the minus sign. Next load plus 71.53 into 2, because 1 plus 1 it is the 2 meter, minus 40 into 1, because this goes minus sign, and we achieve these answers as of 71.86 kilonewton into meter, and the plus sign is there. So I achieve over here is of inclined straight line 71.86. Because between D and E there is not a single load, this 2 points has been joined by inclined straight line. Next, because at G is the point where we found out maximum bending moment, the point at which the shear force is 0, and this distance we know as it is as 0.98 meter. So let us be found out at that particular point M moment at G. Let us be found out moment at G is equal to minus 10 into 1.2 total load, this is my total load, multiply by 1.2 by 2 CG distance plus 1 plus 1 plus 0.98, this much is the perpendicular distance, plus 71.53 into 1 plus 1 plus 0.98. Next, another load which is of 40 and which is of comes minus sign, 40 into 1 plus 0.98, because if I will take a section over here, section left anti-clockwise, the next UDL is there for this much portion, so minus 20 into 0.98, this is the load, multiply by 0.98 by 2, and we achieve, when we solve this simple equation, we can got 81.4. So we achieve at this point the answer is of 81.4. Now let us find out at the B. And how to join? Definitely, because it is a UDL, I have to join with the help of parabola only. But I will join this parabola after finding out the value at B. So let us go ahead the moment at B. So MB is equal to minus 10 into 1.2 into 1.2 by 2 plus 1 plus 1 2, 2 plus 4 6. Next, plus 71.53 into 4 plus 1 5 plus 1 6, minus 40 into 4 plus 1 5, minus UDL 20 20 into 4, that is the load, multiplied by 4 by 2, and we achieve this answer, which is of 20 10 minus 10 kilonewton into meter. So we achieve the answer over here is of minus sign, and this is of 10 value. Minus sign below baseline. I have to join 1, 2 and 3 with the help of parabola. So this is the parabolic approach or diagram. We can plot it out right now. Let us find out at f. Obviously this value is 0, but even though if you want to carry out a check it out, mf is equal to from left to right, as we are going from left to right. In that case, minus 10 into 1.2 into bracket 4 plus 1, 5 plus 1, 6 plus 1, 7. So 1.2 by 2 plus 7 plus 71.53 into 4 plus 1, 5 plus 1, 6 plus 1, 7 minus 40 into the distance is 4 plus 1, 5 plus 1, 6 minus 20 into 5 by 2. Yet one load is remaining, that is of RB plus RB into 1, and this answer must be 0. This answer must be 0, and we can join this with the help of parabolic nature. So this is the way of presentation of bending moment diagram, and that we can find out. So if you have plotted by yourself, please check it out the answer, as this is my maximum bending moment at distance of 0.98 meter. Before we proceed further, the two important things we have to find out over here, this point. I will take this pen. I have to find out one point and the second point. Please recall these 2 points. What is the name of this 2 point? Yes, it is to be known as point of contraflexion. Or point of inflation. Our intention is to find out these 2 points. How to find out? So first judgment or first important visualizations you have to take care. This my point of contraflexure occurs between E and B as well as between A and D. So let us we take a section between E and B, section XX, and let us we generate the equation of bending moment for the same. So let us we can do or perform over here right now. So now if I will take a section XX over here at distance x from E, then moment at XX is equal to minus 10 into 1.2 into 1.2 by 2 plus 2 plus x. So I am interested to find out the moment over here because of all the loads. Plus 71.53 into 2 plus x minus 40 into 1 plus x minus 20 into x by 2. This is the value of bending moment equation, and this equation is valid within the region of E and B. Now at one point of x, this value is 0. So what I have to do? I have to equate this value is equal to 0. So you just understood I have an equation in which only one unknown parameter available to me, which is of x, and I can find out easily the value of x. So find out the value of x from this equation, and this x is nothing but is our point of contraflexure, point of inflation, where bending moment is changes its sign from positive to negative or negative to positive. So now I wish you might have been understood very well how to plot the bending moment diagram, how to find out the point of contraflexure. See in this particular PPT the diagram itself shown over here in this particular PPT. Next, after solving this problem, let us go ahead with the next problem. Yes, given beam, visualize. This much portion is projected beyond the support. There is no projection beyond from this support. This is obviously a one-way overhanging beam. But in this beam, the beam is subjected to the UVL, beam is subjected to the concentrated moment, the beam is subjected to a point load 20 kilonewton, the beam is subjected to the UDL. So all four combinations of the load which has been taken care in this particular problem, and our intention is to plot the shear force and bending moment diagram for a given beam in which the all kinds of the loading which has been given to us. Does it proceed further? Recall the step number 1. The step number 1 for us is find out the support reactions using the 3 equilibrium conditions. So now let us go proceed for the same. See in this PPT. Sigma h is equal to 0. As such, all loads are vertical and one moment is acting, not a single force which is acting horizontal. So RAH is equal to 0. Sigma V is equal to 0. Summation of all the vertical forces are equated with 0. With that, UVL is there, so area of UVL half into 20 into the distance, that is of 2 plus 2.5, that is 4.5, acting downward, negative sign, plus RAV acting upward. Now no contribution of this 30 kilonewton into meter in the calculation of sigma V. So only 20 with the minus sign 10 into 1 plus RB, which is equated with 0, and we achieve an equation RAV plus RB is equal to 75 kilonewton. So we got the sum of the reactions are 75 kilonewton. Let us take sigma MA is equal to 0. Sum of all the forces of moments at A is equal to 0. I am taking a moment over here, and which is equated with 0. Now when I will take a moment over here, so visualize, if I will take a full load over here, then some part having a moment on this direction, some part having a moment on this direction, or otherwise I should know the CG of this triangle. This is one of the tedious procedure to find out the CG of triangle. So what I did, I divided my UVL into two parts, left part and the right part. If I will take a left part first, then half into 20 into 2 into CG distance. What is the CG distance? Is over here. 1/3 of 2 which is acting, carry out a moment of anti-clockwise section, left anti-clockwise negative sign. So you just visualize minus sign, half of 20 into 2 into 1/3 into 2. Now another part of UVL, half into 20 into 2.5 into CG distance, 1/3 into 2.5, carry out a moment section over here, and which is a clockwise moment, so plus sign, half into 20 into 2.5 into 1/3 into 2.5. Next, concentrated moment, plus 30, not at a single distance, plus 20 into total distance, 2.5 plus 1.5. Next, 10 into 1 total load, multiply by distance, 2.5 plus 1.5 plus distance 1 divided by 2, minus RB into 5, because RB multiplied by distance total, 2.5 plus 1.5, 4, 4 plus 1, 5, which is equated to 0. By solving this, we got RB as 32.5 kilonewton. We can able to find out the value RB as 32.5 kilonewton, and RAV as total load 75 minus 32.5, we can get it 42.5 kilonewton. So I wish how to find out the support reactions. It is very easy for you to find out it. So we are able to here found out the value RAV is equal to 42.5 kilonewton, RB which is of 32.5 kilonewton, and RAH is equal to 0. Let us go further. Next is the plotting of shear force and bending moment diagram. So let us go the first number, that is of plotting of shear force diagram on the tabletop. The given beam, the value of UDL is of 10 kilonewton per meter, point load value which is of 20 kilonewton,